So this is going to be working the review problems for Math 201, the second test. So you can see here, I have a series of problems. I think I will try to go and work them out on this review page as long as I have room. If I run out of room, I can work on it elsewhere. So problem number one, looks like there are 2, 4, 6, like 8 different problems where basically we're going to find some derivatives. So I'm going to do these fairly quickly. Hopefully you'll be able to follow along. So this first one, I'm going to apply the power rule. So the 4 is here as a coefficient, sort of tags along. The exponent comes down front. Then you subtract 1 from the original exponent. So the derivative of x to the 4th is 4x to the 3rd. Of course, if you have the 4 as a coefficient, you end up with 16x to the 3rd. Now, as I work out these problems, I'm going to check my answers, make sure I don't mess up, hopefully. All right, the second problem, right away. This problem is not written in a form where we can use the power rule. Remember, the power rule has to be an exponent raised to some number. Number could be a fraction, could be a number, could be a negative number. But here, we've got 5 times the 5th root of x. So what you can do is, in math, sometimes you can rewrite things. And in this case, I can rewrite it so that I can use the power rule. So you remember, anytime you have a radical, you can rewrite a radical as what we call a rational exponent. So 5 is the coefficient. So the 5th root of x is the same thing as x to the 1/5. I'm not going to take the time to show you now how I got this. You should already know that. So now I can apply the power rule. So the derivative dy dx, 5 is a coefficient, tags along. So the derivative of x to the 1/5, the 1/5 comes down front. Then I'm going to subtract 1 from the original exponent. 1/5 minus 1 is -4/5. Now 5 times a 5th is just 1. And I should go ahead and get rid of this negative exponent. So now you could probably leave it like that on the exam, but if you want to change it back to a radical, it would be the 5th root of x to the 4th. C, once again, in its current form, I cannot use the power rule. However, x to the 6th in the denominator, I can move that to the top if I make the exponent a negative. So at this point now, I can apply the power rule. Whoops. So the derivative, 1/4 is the coefficient, minus 6x to the -7th. -6 times 1/4 is -6/4, which is -3/2. I'll move this x to the bottom. Should be -3 over 2x to the 7th. Now going to D, now here we have 4 terms. When you have multiple terms, you simply take the derivative of each term one at a time. So it's almost like 4 separate problems here. I'm going to take the derivative of 2x, derivative of -10, the derivative of square root of x, and then the derivative of 5 over 3x to the 3rd. It's almost like taking 4 separate derivatives. Now the 2x minus 10 I can do now. However, these last 2 terms, the square root of x, and here with this x in the denominator, I cannot use the power rule. So let's go ahead and rewrite those. So the 2x minus 10 is fine. X, I will convert to a rational exponent. And -5/3. If I make the exponent -3, then it goes to the top. So now I can actually use the power rule on each of these terms. Derivative of 2x is just 2. Derivative of -10 is 0. Derivative of a constant is always 0. Derivative of x to the 1/2. The 1/2 comes in front, and you have to subtract 1/2. Now here you got -5/3 times -3, and then you subtract 1 from the original exponent. So if I clean this up a little bit, 2 x to the -1/2, x to the 1/2 goes in the bottom. I will go ahead and convert that back to a square root of x. Now this last 2 negatives make a positive. The 3 and the 3 cancel out. And the x to the -4th goes to the bottom as x to the 4th. So if I check, hopefully, and that is correct. Now, E, hopefully you notice, all of a sudden we're multiplying. You notice 3x times the parentheses, where the parentheses had some x's inside. So really there are 2 ways to do this problem. Normally when you're multiplying, we can think of this as almost like 2 functions, like x times this parentheses, a second function. The rule we learned for situations like this that's pretty easily used is the product rule, which I'm going to go ahead and do that. But just to say, some of you, it would not be too hard to just multiply out these parentheses, and then you would have 3 terms, and then you would take the derivative of the 3 terms using the power rule. Would also not be difficult. But let's just go ahead and use the product rule. So product rule says, first of all, the 3 just tags along. The product rule, I write the first function times the derivative of the second function. Derivative of x cubed minus 2x plus 11. Derivative of x cubed is 3x squared. Derivative of -2x is -2. Derivative of 11 is 0. So this is the first half of the product rule. The first times derivative of the second plus the second, the whole parenthesis, times the derivative of the first, which is just 1. Hopefully you can see. And what I'm going to do is I'm going to multiply out these parentheses. So x times 3x squared is 3x cubed minus 2x, then plus x cubed minus 2x plus 11. Now, if I combine like terms, and I'll multiply out the 3. So 3x cubed plus x cubed is 4x cubed times 3. 12x cubed takes care of that one and that one. Negative 2x minus 2x is negative 4x times 3 is negative 12x. And then 3 times 11 is, so that is correct. I could simplify this and use the power rule, but I don't mind getting some practice for the product rule. First thing I have to do is get rid of this square root. So the square root of x cubed is the same thing as x to the 3 halves. Now, product rule, the first times derivative of the second, 3 halves x to the 1 half. First times derivative of the second plus the second times derivative of the first. Now, this might not be obvious, but I'm going to factor out, oh, x times x to the 1 half is actually 3 halves x. This is really 3 halves x to the 3 halves plus x to the 3 halves. So if I add these together, this in a sense becomes like 2 over 2. So this becomes 5 halves x to the 3 halves. Or if I want to bring back the radical, should be 5 halves square root of x to the 3rd. All right, G and H, let's go get some separate paper to give ourselves room. Because G, definitely going to do quotient rule. Now H, this first term is just power rule, but the second term is quotient rule. So quotient rules can get messy and can take up lots of room. So here's 1G. Y equals 4x to the 4th over s squared plus 2. For the derivative, I use quotient rule, which is low d high minus high d low over the low squared, right? So low d high, derivative of 4x to the 4th is 16x to the 3rd. So low d high minus high d low all of that over the denominator squared. So with some of these problems, there is some simplifying you can do. So I'm going to go ahead and multiply out these parentheses, multiply these together. See how much we can clean this up. So this be 16x to the 5th plus 32x cubed. And this is 8x to the 5th. All of that over x squared plus 2 quantity squared. Now I do have some like terms I could combine. 16 minus 8. 8x to the 5th plus 32x to the 3rd over x squared plus 2 squared. Now I can go on to factor out like an 8x to the 3rd out of the numerator. So it's 8x cubed times x squared plus 4 over x squared plus 2 quantity squared. So let me check the key. 8x cubed. Yep, that looks correct. And then this last one. F of x equals 4x to the 6th minus x minus 5 over x cubed plus 8. So you can see we start with two terms. So I can just take the derivatives individually. And this first one is just a pretty straightforward power rule. This one's a little messier. If I take the derivative of this, it's going to be quotient rule. So that's what I'll do. Derivative of this is just 24x to the 5th minus. Now, derivative of the second term is going to be a lot messier because I've got to use a quotient rule. So low d high, derivative of x to the minus 5th is just 1 minus high d low, derivative of this denominator, 3x squared, all over squared, x cubed plus 8 squared. So probably what I can do is multiply out these parentheses in the top, sort of clean this up a little bit. My guess is I'm going to have two terms as my answer. So minus, so this is just x cubed plus 8. So I've got this minus here. So 3x squared times x is 3x to the 3rd, but it's minus 3x squared times negative 5 is negative 15x squared. All of that over x cubed plus 8. So I guess I can combine a couple like terms, x cubed minus 3x cubed. Sometimes these derivatives are just not too pretty when you're all done. 24x to the 5th. Let's go ahead and going to have negative 2x cubed, and I'm going to bring the negative inside. So it's going to be 2x cubed minus 15x squared. Whoops. I paid attention. Oh, I gotta be careful though. This negative and it should be -8 all over x cubed plus 8 quantity squared. Let me check and see, because I could tell I was starting to lose track of things. Now the key, I left the negative out here, but I distributed the negative inside, and I do get the same answer. All right, so that's all number one, a bunch of derivatives. Now you go to number two, look at the instructions. Find the equation of the line that is tangent to the graph of the given function at the specified point. So we have an equation or a function. We're going to look at this point, x2, y8. This point is on this line, and we want to get the equation of the tangent line at that point. So let's talk big picture. The equation I'm going to use is the point slope equation, which is y minus y1 equals m times x minus x1. X1 and y1 is just the point on our graph, on our curve, on our function. So we know the point, because we're going to look at 2, 8, x2, y8. So I know my x1, y1, if I can find the slope of the tangent line at that point, then I can find the equation of the tangent line. How do I find the slope at this point? Well, you simply take the derivative, because the derivative is the same thing as the slope. So if I take the derivative of this equation, pretty straightforward power rule. There's a derivative, which is really an equation for the slope at any point on that line. So I'm specifically looking at this point where x is 2. So really what I want to do is take the derivative, which is the slope, and see what it is at this point when x is 2. So I plug in 2 for x, 8. Looks like the slope when x equal 2 is 13, or you can say the slope of the tangent line. So now I've got the slope of the tangent line, so I can plug everything in. Y minus y1, which is 8, equals 13. X minus x1, which is 2. It's going to multiply these parentheses and add 8 to both sides. And again, in making mistakes, the equation of the tangent line should be y equals 13x minus 18. That is correct. For B and C, obviously I'm going to need more room. So let me go work over here. So here's 2B. The equation is y equals square root of x minus 4 over x. So the point they're looking at is 4, 1. So same procedure. If I use the point slope equation, I've got my point. I need to get the slope at this point. The way I get the slope is go and take the derivative of this and then plug in x equals 4. Of course, I can't take the derivative of this quite yet without rewriting it. Square root of x becomes x to the 1/2 minus 4x to the minus 1. So now I can take derivative of this. 1/2 x to the negative 1/2 minus 4. The negative 1 comes in front. So if I clean this up a little bit, 1/2 square root of x plus 4/x squared. So that's the equation for the derivative. Now I'm looking at a certain point, x4, y1. So I want to know the slope when x equals 4. So I plug in 4 in for x. 1/2 times square root of 4 plus 4/4 squared. Square root of 4 is 2. 1/2 times 2 is 1/4. 4/4 squared, 4/16. 1/4 plus 1/4 is 2/4, which reduces down to 1/2. So the slope of the tangent line at this point when x is 4 is 1/2. So now I've got everything I need. Here's my point slope equation. Y minus y of my point, which is 1, equals my slope, which is 1/2. And then x of my point is 4. Multiply out parentheses, add 1 to both sides. Oh, let's do the 1/2 x. 1/2 x minus 1. So this is the way they like to write it. So 2b 1/2 x minus 1. And there's one more of these where they're asking you to find the equation of the tangent line. So 2c y equals x cubed minus 20 x minus 1, and the point is 314. You could FOIL this, or you could do product rule. Actually, I think I might FOIL it just for fun. X cubed times x is x to the 4th. X cubed times negative 1 is negative x cubed. Negative 20 times x is negative 20x. Negative 20 times 1 is plus 20. So now let's take the derivative of this. 4x cubed minus 3x squared minus 20. So if I use that point slope equation, I've got my point. Now I need to get the slope when x is 3. 4 times 3 cubed minus 3 times 3 squared minus 20. 3 cubed, 9, 27. 27 times 4 is 84. think it's 108. But I better check. So 3 cubed, 3 times 27, so 27 times 4. 108, that's good. 3 squared is 9. 9 times that's 27. Minus 20. So it's 108 minus 47. Like 61. So y minus y1, y minus 14 equals 61. X minus x1 is 3. If I'm going to get the y by itself, 61x minus 183 plus 14. 61x minus, see if that's correct, minus 169. Yep. All right, so those are 3 problems. You're given an equation and a point, and you're asked to find the equation of the tangent line. 3a and b, second derivatives. These are all power rules, so that's 20x to the 4th minus 9x squared. So second derivative, you do it again. So 4, bring the 4 down, 4 times 20 is 80x cubed minus 18x. That's correct. See if this one we can squeeze in. Let's rewrite the original function, make it ready to take the integral. This would be x to the minus 1. Plus x, convert the radical into a rational exponent. So the derivative is going to be negative 1 times x to the minus 2 minus 20x. Oh, I skipped this one. Plus 1/3 x to the minus 2/3. See if we can squeeze it in here, simplify this thing. Negative 1 over x squared minus 20x actually, you know what? I shouldn't do this because I need to take the second derivative. So let me jump to a sheet of paper. Watch it run out of room. So here was the first derivative. Hopefully, if I didn't make any mistakes. Negative x to the negative 2 minus 20x plus 1/3 x to the negative 2/3. Whoops, that's the first derivative. So now the second derivative of this, negative, the negative 2 comes down front. Derivative of negative 20x is just negative 20. Derivative of this, the negative 2/3 comes down front. So if I clean things up, 2 over x cubed minus 20 minus 2 over 9 I will save it x to the 5/3. So that one was a little messier. Let's see. So that was 3b 2 over x cubed minus 20. All right, looks like I may have messed up on this term here. So let's go back to the very start, make sure I didn't mess up. So that's what happens, especially if you have a key, so that you have the answers. So this is x to the minus 1, x to the 1/3. So the derivative, negative 1 x to the minus 2, minus 20x. Derivative of this one is 1/3 x to the minus 2/3. So I took that and brought it here. Oh, yeah. So minus next to the minus 2 minus 20x plus 1/3 x to the negative 2/3. Second derivative, the negatives here, you bring a negative 2 down front, so that means positive 2, and you subtract 1, 2x to the minus 3. Derivative of negative 20x is just negative 20. Derivative of this, you've got the 1/3, 2/3 comes here, and you subtract 1, which is like subtracting 3 over 3, which leaves it negative 5/3. So 2 over x cubed minus 20 plus negative 2 over 9 x to the 5/3. Now that's not what I have in the key. Now the one thing you can do, so I'm going to do it, so I don't want this to make mistakes. I'm going to go over here on my computer, which you can't see, and I'm going to go to Google and type in derivative calculator. You can actually put in the original function and find the second derivative. So I'm going to do it real quick because I want to see if I've messed up. So it's 1 over x plus the square root of x cubed and then finally minus 10x squared. So I'll go over and hit the button. So let me check, see if I have the correct first derivative. Negative, let me check, negative 10x squared plus 1 over x. Maybe I copied the problem up. What did I do? Oh, you know what? Bad on me. Big mistake. This isn't x to the 1/3. This was x to the 3/2. All right, it's okay. This happens. So I actually did the problem when I converted it to use the power rule. I messed up. So I'm not going to remake this video. I'm just going to do this correctly. Maybe as I was doing it, you saw my mistake. I just kept forging ahead. So what happens is this becomes, when you switch it to a rational exponent, it's x to the 3/2. Now, first derivative, -1 times x to the -2. This becomes 3/2 x to the 1/2. There's a first derivative. Second derivative, -2 comes 2x to the -3. The 1/2 comes down front, like 3/4 x to the -1/2 minus 20. So if I clean this up, 2 over x cubed plus 3 over 4 square root of x. See how that compares to the answer key. 2 over x cubed, 3 over 4 square root of x minus 20. That is correct. All right, sorry about that, but happens to all of us. All right, now I got a couple story problems. So let's just read this. The growth of a bacterial population is represented by the function P of t equals 5,000 plus 1,000 t squared, where P is the amount of bacteria and T is the time measured in hours. Determine, there's 3 parts. The amount of bacteria after 5 hours, the instantaneous rate of growth, the growth rate at 5 hours. So is this an equation that basically we can plug in the number of hours that have passed, and this equation will tell us how much bacteria there is. So that's what we're going to use for part A, because they're simply saying how much bacteria is there after 5 hours. So you simply plug in 5 for T. So it's almost like this. P of 5, 5,000 plus 1,000 . So this is basically 5,000. This is 25 times 1,000, which is 25,000. If you add 5,000. So the amount of bacteria should be 30,000. Don't know what the units are. They don't give us any units. Here's where it gets interesting. Instantaneous rate of growth. Anytime you see the word rate for these kinds of problems, almost always means you're going to take the derivative. So let's take the derivative of this equation. That's going to be part B. And then part C, they're actually going to have us plug in a time of 5 hours, and that'll give us actually the growth rate after 5 hours. So part B is just going to be an expression or an equation. And then in part C, we're going to plug in 5 into T. So basically, I've got my equation here. If I want to know the rate of growth, I'm going to take the derivative of this. Derivative of 5,000 is 0. Derivative of 1,000 t squared, I just use the power rule. 1,000 times 2t to the first. So this is an equation for the instantaneous growth rate. And then the third part, now they want to know what that growth rate is when t is 5 hours. So basically, you want to take the derivative and plug in t equals 5. So 10,000 units of bacteria, whatever that is, over per hour. So at the 5th hour, the bacteria is growing at a rate of 10,000 bacterial units per hour. All right, now here's another start problem, and I will grab a sheet of paper to have room to work this one out. Cost of producing airplanes is given by C of x equals 2,000 times x squared plus 2, all raised to the 1/3 power plus 700, where Cx is the total cost in thousands of dollars of producing X airplanes. Find the total cost to produce 20 airplanes and the rate at which the total cost is changing when 20 airplanes have been produced. So once again, it's really a two-part problem. The first half of the sentence says, find the total cost to produce 20 airplanes. Here's an equation that gives me the cost based upon how many airplanes have been produced. So I simply put in 20 for X and then do this math. So it's almost like C of 20 is going to be 2,000 20 squared plus 2, all raised to the 1/3 power. So it doesn't really tell me how to round it. So 20 squared, I know it's 400. I got my calculator. 400 plus 2, that's 402. I need to take the cube root of it. So the cube root, you can see there's the cube root of 404 times 2,000 plus, now probably you're going to round it to the nearest dollar. That's interesting how this answer is 15. I'll round it to 461. But you notice here, the total cost in thousands of dollars. So that means this actually isn't dollars. This is a number, but to get the actual cost, I then have to multiply by $1,000. And then you get the actual, like 15,461,000. Now the second part of the question is, and the rate at which the total cost is changing when 20 airplanes have been produced. So you take your equation and you want to see how things are changing based upon the number of planes that's being produced. So you simply take the derivative Now in this case, well, we haven't done it yet. This is really going to be like a chain rule problem, because you're going to have the 2000 out front. Then to take derivative of this, you bring 1/3. So this is the outside, x squared plus 2, and you subtract 1, and then derivative of 700, 0. So if I clean this up a little bit, it's almost like 2000 over 3 times the cube root of x squared plus 2 squared. Wow, pretty messy. But now they want to know what it is when x equals 20. So I plug in 20 right here. Twenty squared is 400. So once again, you have 402 squared. So let's grab my calculator. 402 squared. Then I'm going to take the cube root of that on my calculator, multiply it times 3. Needs to go in the bottom of a fraction times and we will see. All right, looks like my numbers are not matching the key. So what do? You go back and see if you made any mistakes. Let's check our derivative. So 2000, 1/3 comes in front, x squared negative 2/3. So 2000 over 3, it's a cube root of x squared plus 2, all that squared. So when you plug in 20, 20 squared is 400 plus 2, 402 squared. Let me do the math, this calculation again. So 402 squared. And then it has to be the cube root times 3. And then times. So I get 12.24. And if you multiply it times 1,000, so let's do this again. Let me go, I'll make sure I did the derivative correctly. So maybe the key is wrong. Sometimes that happens. So the original equation is 2000. Oops. $2,000 in parentheses x. Oh, you know what? I didn't finish the chain rule. I just saw that. Chain rule says then you multiply by the derivative of what's inside. Wow. I forgot the second half of the chain rule. So this then becomes like 2x times 2000, which is like 4000x. So it's 4000 times 20. Maybe I found my own mistake. So 402 squared, And then the cube root times 3 equals, all that goes in the bottom, times 4,000 times 20. No, I think I did the math wrong again. 402 squared. And then the cube root of that times 3. It's going to go in the denominator times 4,000 times 20. 489.57. All right. Actually, 574 multiplied by 1,000, and you get 489,574. All right. Another mistake. I didn't do the chain rule correctly. So hopefully you realize what I did when I was taking the derivative of this. 2,000 chain rule. So 1/3, write your parenthesis, subtract 1 from the exponent, and then multiply by the derivative of what's inside. I forgot the second part, which would be 2x. So I forgot this 2x originally. All right. That's the kind of things that happen if you're not being very careful. Matter of fact, get to number 6, and we're going to do some derivatives, and these are chain rule problems. So now we're going to get lots of practice. Parentheses raised to an exponent. So the derivative of this one. So outside first, bring the 5 down, simply copy what's inside the parentheses and subtract 1 from the exponent. Then don't forget, which is what I just forgot, you take the derivative of what's inside. So the derivative of 3x plus 8 is just 3. I try and simplify this. 15 times 3x plus 8. All that raised to the 4th power. So this one, once again, parentheses raised to an exponent. Derivative, so the outside, the 50 comes down front. 18 minus x, subtract 1. And then now you multiply by derivative of what's inside. Derivative of negative x is just negative 1. So the answer should be negative 50 times 18 minus x raised to the 49th power. Now C, we can't immediately apply the chain rule because all the stuff's in the denominator. However, I can rewrite it and move that whole parenthesis to the top and make the exponent minus 3. So now I can apply the chain rule. So the outside negative 3, copy down the parenthesis, and you subtract 1, and then multiply by the derivative of what's inside, which is just 5. So if I clean this up, looks like negative 15 over 5x minus 16, all to the 4th power. This one, I'm probably going to need to do it on some paper because it's starting to get a little messy. So problem D, let's go over here. So this is 6D. Y equals 4x to the fourth over 3 minus 5x quantity squared. So I'm going to use a quotient rule, although I think at some point I'm also going to have to use the chain rule. Quotient low, D high, derivative of this is going to be 16x to the third minus high, D low, derivative of the bottom is going to be the chain rule. So the 2, you copy down the parentheses, you subtract 1, and then you multiply by the derivative of what's inside the parenthesis. And then you take the denominator and you square it, which means it becomes to the fourth. Now, should probably try and clean this up some. Let's take 16x cubed. Let's multiply this out, FOIL it. So it's going to be 9 minus 30x plus 25x squared. Oh, this is going to get messy fast. -5 times 2 is -10 times -4. 40x to the fourth, 3 minus 5x. Multiply out these parentheses. So I want to just see what kind of answer the key has. Yep, tried to simplify it. Although I'm looking at this. Well, let's keep going. 16x cubed times 9. It's 90 and 54. I think it's 144x cubed. 16x cubed times minus. So 16 times minus 30. -480x to the fourth. And then 16x cubed times 25x cubed. Plus 400x to the fifth. So 40x to the fourth times 3. 120x to the fourth. And 40x to the fourth times 5 is going to be -200x to the fifth. I'm checking to make sure. Once again, I'm going to go check this real quick. So it's 4x to the fourth over 3 minus 5x quantity squared. All right, so this one's pretty messy. I'm trying to see. It may be correct. Let me just keep going. So, oh, you know what I think they did instead of multiplying all that stuff out? How about if I just factored out a 3 to the minus 5x? So if I do that, so this is just messy algebra. Actually, I could factor out a, so this is subtract. Let's do this. Let's just call this 16x cubed, 3 minus 5x squared. And this is going to be plus 40 x to the 4th. And all that is over. It's only a matter of simplifying. So let's factor out a, looks like I can factor out a 4 or maybe even an 8. And 8x cubed. And then parentheses, 3 minus 5x. So when I do that, I'm going to have 2 times 3 minus 5x. Then for the second term, simply going to be 5x. So this is just very messy algebra. So this 3 minus 5x and 3 minus 5x to the 4th, that cancels and that becomes to the 3rd. Inside here, it's going to be 6 minus 10x. So it should be 6 minus 5x. All over 3 minus 5x to the 3rd. And this looks very close to the answer, except looks like my signs are off, so I probably wasn't careful with my minus signs. Let me see where I could have messed up on my minus signs. Oh, no, it's okay. I think this is correct. So if I want to get the answer in the key, at this point, I'm going to what is this, D? I'm going to go and multiply out these parentheses. And that is the answer in the key. So I didn't make any mistakes. When I simplified, I probably made it worse than it had to be. So that happens sometimes. So that was 6D. So now 6e looks messy, but I don't think it's as bad because it's just going to basically be 2 chain rule. So by that, I mean the derivative. This one is a chain rule 4 times 6 plus x to the 4th. So here's the outside. Then the derivative of that is 4x cubed minus chain rule for this one. The 3 comes down, right? The copy the parentheses, subtract 1, and now the derivative. So I think basically all we're going to do is maybe 4 times 4x cubed is 16x cubed, 6 plus x to the 4th raised to the 3rd, minus 24x to the 7th, 2 plus x to the 8th. So 6x cubed, 6 plus x to the 3rd, minus 24x. All right, that's what the key has. So continuing on, this f, let's first rewrite this. Square root becomes exponent of 1/2. So now, derivative of the chain rule, 1/2 comes down here, x cubed plus 3 to the minus 1/2 times derivative of what's inside, which is 3x squared. So if I try and clean this up, I believe it's going to be 3x squared over 2 square root of x cubed plus 3. So this is f. That's correct. Let me get a piece of paper for G. Looks interesting. (6g) y equals x plus 7 there's probably a couple ways to do this. Trying to think what, because you could split this up into 2 separate in other words, here's what I'm trying to decide what would be, because I can rewrite this. I think I'll probably go with this. And I'll use the quotient rule. I'm probably gonna have to also use the chain rule. So low d high, derivative of this top is going to be the chain rule. Derivative inside is just 1 minus high d low, chain rule again, all over now. Maybe some x plus 3s cancel out. I guess 3 of them maybe. So I'm left with x plus 3 minus 4 x plus 3 to the 5th. I can factor out x plus 3 to the third, and also factor out a 4. So once again, this is just some algebra. So there's the first term minus all that over x plus 3 to the fifth. If I multiply out these parentheses and combine what's inside here, I'm going to have 4x minus x, which is 3x, and 12 minus 7. Let's see if there's any way that's actually the answer. So this is 6g. And I wonder if I made a mistake. So let's go back. So low D high, chain rule, it's 1, minus high D low, 1. So then 4. So I canceled out x plus 3 to the third. So it left 1 here minus 4 times all of that over that. And then I factored out a x plus 4, x plus 7 to the third. Oh, should have had this here. Yep, that's my mistake, that 4 there. Because now this is going to be x minus x. And it's just going to be 3. It's going to be negative 4. This whole thing is gone. So negative 16. Yep, that's a correct answer. So that one mistake right there. Maybe you saw it as I was doing it. Yeah, so these are pretty messy. As a matter of fact, just because of time, like H here, that's not going to be, you're not going to have one that messy on the exam. So let me just go and skip this, take a pass on it. And let's do some of the rest of these, which is something more likely to be on the exam. So number 7, implicit differentiation. So that means I'm going to take derivative of both sides with respect to x, right? Derivative of y squared is 2y times dy dx minus derivative of x squared is just 2x. Derivative of 1, 0. So if I want to solve for dy dx, I'll add 2x to both sides. To solve for dy dx, divide both sides by 2y. And you get dy dx equals x over y. Same thing here. Take derivative of both sides. Here's product rule. So the first times the derivative of the second plus the second times derivative of the first That equals derivative of the constant, which is 0. So subtract y from both sides. Divide both sides by x. dy dx equals negative y over x. So we have 9. Let me do that on a separate sheet of paper. So number 9 is 4x cubed plus 7xy squared equals. So I'm going to take derivative of both sides with respect to x. So derivative of 4x cubed, it's pretty straightforward. Here, 7xy squared, it's like a product rule. So the first times the derivative of the second plus the second times derivative of the first. Now derivative over here. So this is, make sure I copy another problem correctly. I'm sort of messy. It is 2y squared so let's get rid of all these parentheses. So 12x squared. So 7 times x times 2y dy dx. So it's 14 xy dy dx plus 7y squared equals 6y squared dy dx. Now let's get all the terms with the dy dx on the right side and everything else on the left-hand side. So 12x squared plus 7y squared equals 6y squared dy dx minus 14xy dy dx. I'm going to factor out a dy dx over here. So create some parentheses. I want to get dy dx by itself. I divide both sides by this whole parenthesis. Then I have dy dx equals 12x squared plus 7y squared over 6y squared minus 14xy. That is correct. Now we're going to do some more implicit differentiation, but now they want us to find the equation of the tangent line at the point. So I need to get the derivative of this, plug in the 0.42 to get the slope, and then go from there. So here's number 10. I'll just write it out. The equation is x squared minus y cubed equals 2x. And the point is 4, 2. And they want to know the equation of the tangent line at this point. So I need to get the derivative of this. So I'm going to take the derivative of both sides of this. Derivative of x squared is just 2x. derivative of y cubed is 3y squared. dy dx. Derivative of 2x is just 2. So I need to solve this for dy dx. If I move this, sort of move things around, move this over here, this over here. Did a couple steps in my head, but let me do it out in case some of you get confused. I'll subtract 2x from both sides. So I'll divide both sides by minus 3y squared. And if I happen to multiply top and bottom by minus 1, I get rid of a lot of the negatives. And you get that. So now I need, this is my derivative or my slope. I want to find it at this point. At the point 4, 2. So I plug in 4 for x. 2 for y. 8 minus 2 is 6. 3 times 4. Looks like the slope is 1/2. So now point slope equation. Y minus y of my point, which is 2. My slope is 1/2 x minus x of my point, which is 4. Get the y by itself, 1/2 x minus 2 plus 2. Looks like the equation of the tangent line is y equals 1/2 x. And then 11, same kind of problem. X cubed y minus y cubed x equals 30. And the point we're looking at is 1, 3. So once again, need to find the derivative. So take the derivative of both sides. So this is going to be a product rule. The first times the derivative of the second minus the second times derivative of the first. That's for this one. Minus, now derivative of this, product rule again, the first times derivative of the second minus the second times the derivative of the first. L equals 0. So let's clean all this up a little bit. So it's like x cubed times dy dx minus 3x squared y minus y cubed plus 3xy squared So I'm going to factor the dy dx. I'm going to move these to the other side. X cubed plus 3xy squared equals 3x squared y plus y cubed. So it's pretty messy, but if I didn't mess up, here's a derivative, 3x squared y plus y cubed over x cubed plus 3xy squared. So I want to find this at the point 1, 3. Plug in 1 for x, 3 for y. 3 times 1 squared times 3 plus 3 cubed. X cubed is just 1 plus 3 times 1 times 3 squared. It's like 9 plus 27. 1 plus 27. 36 over 28. If I reduce that, it's 18 over 14. If I didn't mess up, 9/7. I'm a little suspicious because when I look, let's just check my work. That's what you always do. So product rule. First, derivative of the second minus the second derivative of the first. Oh, not subtract, it's multiplied here. See, I'm not careful. This is multiplied. It's not subtracted. And then the second half of the product rule is first rid of the second. Oh, it's actually plus, right? Product rule, first rid of the second plus the second derivative of the first minus, so the first or the second plus the second derivative of the first. So this is so now factor this out, it's x cubed minus 3xy squared over, this is actually negative here, negative and negative. So when you put the numbers in, this is a negative, this is a negative. So this is -9 minus 27, which is 18 over, this is -27. So it's -26. -9/13. And that was what I was expecting. So now, point slope, y of my point, oh, it's right here, just 3. My slope 9/13 times x minus x of my point, which is 1. Get y by itself, -9/13 x plus 9/13 plus 3. Combine this is 39. I think it should be 48 over 13. And that's correct. All right. Some pretty messy algebra. So I'm making mistakes as I go along, but I can check the key and usually find my mistakes. Now we have two, I think, related rate problems. A certain floating cap of sea ice has been shrinking since 1980. The ice cap always shrinks in the summer and grows in the winter. Average minimum size of the ice cap in square miles can be approximated as. So here's the area of the ice cap. In 2013, the radius of the ice cap was approximately 775 miles and was shrinking at a rate of approximately 4.9 miles per year. How fast was the area changing at that time? So with these problems, like I showed you in class, they're going to give you some kind of equation. And we're going to turn it into we're going to introduce the time factor. So things are now changing in time. So we're going to take the derivative of both sides with respect to time. So this is going to be dA dt. Pi is a number, so it comes out. Derivative of r squared is 2r. So I've really got three things. How is the area changing? The rate the area is changing, the radius, and the rate that the radius is changing. Now let's see what they tell us. And then we probably need to solve for one of these. The radius of the ice cap was approximately 775 miles. So the radius, so they tell us r, 775 miles, and we're shrinking at a rate of 4.9. So the radius is shrinking at a rate of 4.9 miles per year. Since it's shrinking, that means the rate is a negative number. How fast was the area changing? So like I said, we got three things here. They give us two, and they ask for the third. Pi times 2 times 775 miles times dr dt, negative 4.9 miles per year. So grab my calculator. Pi times 2 times 775 times 4.9, which is all going to be negative 23,860 square miles per year. That's correct. And the last problem, another related rate. When expanding without gaining or losing heat, the pressure P and volume V of a sample of argon gas. So once again here, pressure times the volume raised to the fifth to the power equals K, where K is a constant. So K is like a number. Suppose the volume of the samples is increasing, so stuff is going on. Let's turn this into a time problem by taking the derivative of both sides with respect to time. Left-hand side, we got a product rule. First times the derivative of the second. 5/3 V to the 2/3 times dV dt plus the second times the derivative of the first dP dt equals 0. I'm not even going to try and simplify this. I'm just going to try and plug in now the numbers and just see if I can figure it out. Suppose the volume of the sample is increasing at a rate of 0.4 liters per second. So the volume is increasing at a rate, that's dV dt, 0.4 liters per second. How quickly is the pressure decreasing? So they're wanting to know how quickly the pressure is decreasing. When the volume is 2.7 liters, and the pressure is 80 kilopascals. So in other words, we got four things: P, V, dV dt, dP dt. And they gave us three of them. The only thing they didn't give us is dP dt, so that's what we're going to solve for. So let's just plug in these numbers. P is 80 times 5 for V is 2/3. dV dt is 0.4. V to the 5/3 is 2.7 to the 5/3 times dP dt, which we're going to solve for. So this is definitely a good calculator problem. 2.7 to the 2/3. So 2.7 raised 2/3 is 0.666666, goes on forever. I'll just say 0.666666 times 5 times 80 divided by 3. And also times 0.4, this right here. So this is like 103.41. So this one's 2.7 raised to the 5/3 is 1.66666666. Did it say it was decreasing? Oh, increasing. All right. 5.235. So move this to the other side. If I haven't messed up, it's going to be like this. Negative 19.75 kilopascals per second. That is the correct answer. All right, so not too bad. Made a few math errors, caught a few problems, but that's pretty realistic. So anyways, hope this helps you as you're preparing for the exam to try and work through these problems.